Our lesson for today is about Introduction to Variable Frequency Drive (VFD) AC drives. Variable Speed AC Drive Basics has a three objective. Objective 1 describes the function or operation of two common types of variable AC drives. Objective 2 describes the advantage and disadvantage of using an AC drives instead of DC drives. Objective 3 describes the advantage of starting a motor with an AC drive instead of a line starting. When AC power drive a motor, the input voltage creates a moving magnetic field that turns the rotor. The speed of the magnetic field depends on the frequency of the AC power. The higher the frequency or the cycle per second, the faster the motor turns. Most utility power cycle at 60 Hz, which power motor at one speed. Variable speed drives switch that utility power to other frequency to vary motor speed. Variable speed AC drive changes the frequency and voltage supplied to AC motor. Changing the frequency changes the rotation of the magnetic speed, which turns the motor faster or slower. When the motor turns faster, they need a higher voltage to deliver the same amount of torque. General purpose drive describes one common type of variable speed AC drive is a general purpose drive. This drive has three stages to convert AC power into DC power, and filter it, and then turn it back into AC power at different frequency and voltage. The rectifier section uses silicon-controlled rectifiers, or diodes, to convert the incoming AC power into DC power. The DC output contains ripple voltage that is smoothed out in later gained stages. When incoming AC power is first applied, most AC driver rectifiers pre-charge or ramp up the voltage. Pre-charging avoid a large inrush current that can blow fuses or damage diodes. A pre-charge time of more than a few seconds indicates the rectifier has failed. DC link. The DC link is a filter and gain stage that flattens the ripple of the rectified DC signal. It also boosts or decreases the DC voltage to the level needed for the overall output frequency. Some AC drives can call this stage the DC bus. The inverter section converts the DC back into a AC signal that feeds a three-phase motor. Simple inverters consist of six high-powered transistors that produce square pulse. More complicated inverters reduce the distortion of square waves using a process called fuse width modulation, or PWM. Inverter drive switching. The switching of this device is typically controlled by a microprocessor, which is contained in the control section of the drive. The microprocessor is programmed to turn the transistor on and off in a specific sequence to produce the AC signal that runs the motor. The rates at which the switching device are switched controls the frequency of the AC output and therefore the speed of the motor. Vector drive. Vector drive has a feedback added and use more complex control logic that general purpose drives do. Vector drives use a encoder or resolver to provide speed and direction feedback from the motor to control section of the drive. Because of the feedback capabilities of the vector drives, they can provide more accurate controls of a motor speed and torque. Therefore, vector drives are usually more expensive than general purpose drives. Some of the recent vector drives developed do not require encoder or resolver feedback. For example, Allen Bradley has developed a vector drive that can be programmed for a specific motor. Many of the operation parameters of the motor are pre-programmed, and the vector drive controls the motor based on those parameters. These vector drives are called sensorless vector drives. Advantage of using an AC drive instead of a DC drive. AC induction motor and DC brush motor work by similar principle, but their construction and control are very different. Using a AC or DC drive depends solely upon the type of motor used. AC drive shift the AC power's frequency to affect an AC motor speed. DC drive vary the DC current to adjust the speed of the DC motor. AC motor use a AC power to drive a squirrel cage induction motor. This design keeps the motor smaller and lighter than a DC motor of equal power. Parts do not run by friction, so this design is very efficient in converting input power to torque. They require little maintenance, cost less, and run quieter and cooler. Disadvantage of using an AC drive instead of a DC drive. DC motors use brushless to touch the rotor cumulator and deliver DC power. These brushes require constant maintenance. This design directly powers the rotor, so it has more accurate speed control than an AC motor. DC motor also have much higher starting torque. DC motors also deliver constant torque at low speed and can run overload to brief periods. AC motor cannot do this without feedback system. The construction of an AC induction motor is less complex than DC motor. This results in a longer life with less maintenance that is quieter than a DC motor. The AC motor is more suitable since it has capable of bearing torque at lower speed. AC induction motor has a lower starting torque and draw less current than a comparable DC motor at startup. Advantage of AC drive motor starting. Reduce mechanical stress. Unlike line started motor, high inertial loads started with an AC drive can be accelerated slowly. This practice allows the use of a smaller motor. Multiple motor control. AC drive can control multiple motor and accelerate them at the same time. This allows machines that have multiple motors to be controlled with one AC drive. Built-in braking. Most AC drives has built-in braking capabilities that can be programmed. Line starters requires additional contractors and circuitry for braking. Soft start drives. Smaller AC drives are used in many applications in place of regular magnetic motor starters. These drives are often referred to as soft start drives. So, soft start application includes pumps, conveyors, grinders, and fans. Line of single phase power. Another important feature of some AC drives is that three-phase power is not needed to control a three-phase motor. Some AC drives are capable to use single power and produce three-phase signal to operate a three-phase motor. This allows locations that not have three-phase power readily available to use three-phase motor. Thank you for listening about introduction to variable frequency drive, AC drives.